Hey, Nicole,
Yeah.
did you get your Excel figured out?
Yes, I did. Yeah, that video helped me.
Oh, thank goodness. Okay. So I opened the homework back up for you.
Okay.
So go ahead and try to get that done, okay?
Okay.
I'm glad that you were able to get it done. And Adriana, you have yours figured out. You have the tool pack now?
I still don't have the tool pack because
Okay, did you? Oh, go ahead.
I don't have the file option. I watched the video and stuff, and I downloaded everything, but I don't have a file option, so I can't go through to get the tool pack.
Okay, so I need you to try to get with that Denise Henry.
Okay.
And uh, there is some software that you can use through the university. So you need to get with her to see how you can get that software.
Okay.
And at the very last case resort, you could borrow a device from the university, like a computer that has it on there.
Okay.
Okay, so you need to get with her as soon as possible so you can get access to the program. So, because you're going to need it for the rest of the semester,
Okay.
or for the next 2.5 weeks. So let's get that squared away for you, and then we'll definitely be like, I'll work with you on being able to get your assignments done. Okay.
Okay. Sounds good.
Okay.
Adriana, do you have a Mac?
Yeah, I do.
Okay, I do too. And you have like Macs are completely different. You have to go
Yeah,
to the tool tab.
the tool tab.
Yeah, I had
Yeah.
to do it different too for my Mac.
Okay.
Yeah, I literally Googled data analysis tool pack on like for Macs,
Uh-huh.
and it did step-by-step instructions.
Okay.
But she can't find on I guess on the Mac, you go to under File.
No, not on Macs. On Macs you go to tool.
I don't have a tool option either.
Really? So like when you go to the top, it should say like file, edit, view, insert, format, tools, data,
Like at the
Windows,
very,
help.
very top, like not on Excel, like on your actual.
Yeah.
Oh, okay, okay. Oh, okay.
And then at the very bottom, it says Excel add-ins.
Okay.
Yeah.
All right, cool.
Oh,
Appreciate it.
do you see it, Adriana?
Yeah, I got it.
Oh,
And you just
yay.
select the tool pack and the solver add-ins, and then it should work for you.
Okay.
Yeah.
Thank you guys. Appreciate it.
No
Oh,
problem.
that's awesome. That's really awesome, because that'll save you a lot of time and energy. Thanks, you
I
guys.
had to start with that too, but yeah.
Appreciate it.
Yeah, and I don't really know anything about Apple products, so I was kind
Yeah.
of like, crap. But then I did last night at like 11 o'clock. I was like on YouTube looking, and I found a video, and I think it helped you, Courtney, and Nicole. So I think you were able to get it, right? Or Courtney, you still didn't figure out what happened, but you got it, right?
Yeah. I think I had like gone in and was like trying to like add it in again to like the new Excel. So it was like removing it instead of putting it in or something. I don't know. But it ended up popping back up. So I was like, okay.
Okay, so good. Okay, Adriana, so that's awesome. So same thing, make sure you get your assignments completed now that you have that.
Okay.
Okay, good. Okay, great to see all of you. So I saw that several other people sent me some articles, and it looks like maybe some people found some other scales. So let's kind of talk about what you guys found. And I sent you guys that brief sexual attitude scale that I have found. So what do you guys think? What might we want to use? Because for sure we're going to divide up by people that had sexuality education versus people that didn't have any sexuality education. And I'm not exactly sure how we want to do that, if we just want to say yes or no, or if we want to find out like how many times, because that's the other thing, is someone could say, yeah, I had sexuality education, but it was like one day in 5th grade. you know, versus somebody that took a health class in 8th grade or 9th grade where they had a whole class that talked about, and maybe a whole, you know, like 2 weeks on sexuality education. That's very different than maybe one day in 5th grade where the coach just talked or something. So how do you think we can divide that up? Or do we want to ask if they felt like they had good education from their parents or nothing, you know? Because like for me, my parents never said one word to me about anything. Like not even, like my mom never even talked to me about getting my period. I mean, nothing, not even one word. So, and then other people, their parents talk to them about it all the time. So what do you guys think?
I don't know. The only other idea I had was like maybe how the attitude of the people teaching you, like if it like rubbed off on you, you know, like if the teachers or the parents that were talking to you had like a negative attitude, if you grew up having like a negative attitude towards sex or like vice versa, you know?
So
I
the
don't know.
people around you, so maybe like your social norm, like your teachers and your parents, did they have a healthy view of sexuality
How that like could
versus,
have affected you, you know?
right, versus maybe a negative view of sexuality? So we could even maybe say it that way. Did your social norm, your teachers and your parents have a positive, healthy view of sexuality versus maybe a negative? And again, that's attitudinal. That's from that person's perspective. But I don't know what that might work. Catherine, did you have it?
Yeah. So I was basically following what you were saying about how your parents didn't really talk to you about it. So in the discussion, that's what I put in there. Like, what age did people first get that talk, if they ever got any type of talk? So I feel like that should be put in our survey. That's what we're doing.
So maybe how old they were when they first had healthy sexuality introduced to them.
Yeah, if any, or how they acquired that knowledge.
How did they learn? How did they learn about sex?
Yeah.
From their peers versus from a teacher or their
Yeah.
parents?
Mm-hmm.
That might be very interesting. Anybody else have any other thoughts? Courtney?
I feel like it would be important, like, to have a combination of, like, as Sierra and Catherine are both saying, and then along with that, figuring out how exactly the class rubbed off on them and how they gained the knowledge that they needed, or how exactly they went about, like, sexual encounters beyond the education that they just received. Like, it kind of like how it allowed them to learn more about the topic.
Okay. So how how did the education then affect their decisions? Is that what you're saying?
Yeah.
Okay. Anybody else have any thoughts? Rachel?
We could do, I guess, like how in depth of sexual education they got, because I know in my school, my teacher, he didn't hold anything back. He was like showed like pictures of what could happen if you didn't have safe protected sex or anything. And I know one of my friends who went to a Christian school, they left a lot out.
Right. So maybe it was mostly abstinence, or maybe
Yeah.
not anything really straightforward. It was just like, oh, you could get a disease and then that was it.
Yeah, they didn't show like what the diseases looked like or
Right.
how you could get them or what they could do to you.
Right.
So,
So maybe we might want to ask, like, did you have formal sexuality education? And then to find out the depth, we could maybe have them do like a rating from 1 to 10. Because like if your parents talked to you one day about it, or you got it one day in 5th grade and it was just kind of a gloss over, versus if you had a whole curriculum, or your teacher, your parent was just really honest and open and straightforward, versus kind of glossing over it or leaving a lot out? Did any of you guys have, like, did your parents or your school, like Rachel shared that her teacher was just really honest, open, straightforward. Did anybody have that?
I did.
Catherine, you had that? From school or from home or
I had mine at school.
at school, and it was really like honest, straightforward, good information?
Yeah.
Mine was both school and home.
School and home?
Mhm.
So Catherine, was yours like in a health class? What age was it at?
So I went to two different school districts. The first one, they introduced it, like it was like a program, like a pep rally type of thing. And then
Okay.
they gave us products. And then the second school district, it was in the health class. So different health classes in the different grades. We
Okay.
would spend like 2 weeks on it.
Right. Okay. So it does seem like we're going to need, and then other people, how many of you didn't really have much education? Sierra, I know I had like 0. Even at school, but I mean, that was a long time ago, but it was just like, the only thing I had, that's not true. I did have a thing at church. There was a thing at church for like 1 day, and that was it. So, okay, so it sounds like we do need to ask how in depth. We might need to ask them how, I'm not exactly sure how we're going to word that. How in depth was the education, or maybe the whole thing about what was the attitude of the people teaching it. I don't know. I'm not exactly sure how we're going to do that. I'm open to any ideas, because I know we need to ask them, have they had formal education or have they not had formal education? And maybe we want to just stick with, did they have formal education in school? Maybe we want to just stick with that. Do you think? Or do we need to include home?
Well, if we're doing like sexual education, I think we should do like if it was in school,
Okay.
because like I know my parents, that was like a subject they didn't want to talk about. So like my mom got a condom and a banana and was like, this is how you put it on, and that was the extent of our talk.
Well, that's a lot more than some people get.
Yeah, well, I can't look at bananas the same, so
Yeah. As you can imagine, my poor kids, I bring it up constantly, and they're just like, "Oh my gosh, Mom, seriously."
we could say, we could ask like how long of a
Oh, that's
lesson it
good.
was.
Maybe how
So
long was the education? Was it like one session versus?
was it like one class period? Was it 1 week, 2 weeks, a month? Because ours was half the semester. Like we
Okay.
spent a week on each STI, and then we spent a week on childbirth, and we had to watch an entire video on it. And
You saw the miracle of life, or whatever that video is.
oh yeah.
That video is pretty like all out there.
Yeah, we watched it in health class in 9th grade, and then they made us watch it again in anatomy, 12th grade.
Okay. Interesting.
So,
okay, any other ideas, Catherine?
I wanted to say that if you want to go with anything to do with parents, I know that when they had the sexual education course in school, parents could opt out of their child receiving it. So I feel like we can say something about that if we're going that route. I don't know.
Yeah, that's something, it's like, I think your parents do have a really big influence, but we need to keep it as simple as possible. It's really, I mean, if we were doing it for an actual study, they're thinking about like, okay, we want to do this for an actual study and look at doing a poster presentation or getting it published or something. then we would want to be looking at all these aspects. But for the sake of this course, we need to collect some straightforward data that we can easily analyze. So, and we only have, like, we've got a week to get it together. So I think we need to maybe do something we need to simplify it as much as possible. So I really think you need to look at, did you have sexuality education or not? And then, or maybe we need to say, like, how about this? How about if we say, I had at least five sessions of sexuality education in a school-based setting, or I less than 5 sessions of sexuality education in a school-based setting, something like that. Maybe we set a level, like I had at least 5 sessions of sexuality education that was straightforward and presented in a positive way or something like that, or I didn't. And then that's how we divide. We say, this is somebody that had pretty good sexuality education, and this is somebody that maybe didn't have much or nothing at all. And that's how we can divide into 2 groups. What do you guys think about that? And that way we have 2 groups, and it is still self-perception. Like, I would say Rachel would say, I had pretty good sexuality education, right, in school. I had half a semester, and I had it at different levels, where, like, Sarah would say, I didn't really get anything, right, in school. So what do you think about that? Would you guys be okay with that?
Yeah, I think that's a good survey to ask people.
Okay, so I think we need to be able to separate our people into 2 groups so we can do some comparisons or see if there's differences. So I think we need to somehow divide them into 2 groups. One group that felt like they had pretty decent sexuality education, whether we want to say 5 sessions or 10 sessions or something like that. And then another group that says, no, I don't feel like I got very good education. Either the person had a negative attitude about it, or I just didn't have that many sessions or whatever, versus another group that says, yeah, pretty good sexuality education in school. So we'll do that. Then we have to measure something. Like, what are we going to measure? Like, are we going to measure attitudes? Are we going to measure behavior? Because we've talked a little bit about, like, there was that behavioral scale. So it might be like age of first sexual encounter. It might be, so number of sexual partners. It might be STIs. Or we could just look at attitudes. You know, we have that brief sexual attitude scale. So maybe we could look at, like, there was a scale on contraception. There was a scale on, like, I'm trying to remember what the other things were. Sexual permissiveness. There was another scale on, like, purpose of sex. So maybe we want to use something attitudinal. What do you guys think? Would you want to do something more behavioral, or would you want to do something more attitudinal?
I'm gonna say, sorry, go
Jordan?
ahead.
I think if we're giving this survey to people that we know, they might be more comfortable doing their attitudinal towards sex. Because if I ask my parents, hey, when was your first sex? I'm pretty sure they won't tell me, even if it's on a random survey.
Right. Okay, and remember people are, this is going to be through SurveyMonkey, so it'll be anonymous. But I understand, Jordan, people sometimes feel like, okay, well, maybe this person's going to see my answer. So whenever we ask about sexual behavior, it is a lot harder to get feedback than sexual attitudes, because some people are much less willing. Some people will tell you anything, right? They'll just be like, sure, and they'll just tell you. But some people feel a little less comfortable. Sierra, what were your thoughts?
No, that's just exactly what I was gonna say. Like, maybe people's behaviors don't necessarily match their, like, attitudes about it. So I was gonna say attitudinal would be good, I think.
That's true. Okay, so maybe, are you guys feeling okay about using maybe one of those attitude scales? Is everybody okay with that? Okay, yes? Okay, perfect. And I think, Nicole, you said attitude. I think I saw a chat from you. Although, let me get my chat up. Yeah, so Nicole's good with attitudinal. Okay, so that sounds really great. It sounds like we're going to divide people by, I had a pretty good school-based sexuality education that was positive, open, healthy. Not so much. I didn't have a good experience with that. Okay, we're going to divide them up that way, and then we're going to look at attitudes. So should we do the permissiveness? Should we do the because the permissiveness had like 10 questions, so it might give us a scale. Or should we use something like the questions on birth control, or the, I don't know, what do you guys think? I think the permissiveness scale would be interesting. I mean, not that I'm judging that. People have to make their own decisions, but I think it might be interested, or maybe we look at the permissiveness and the birth control. What do you guys think? Should we do both of them?
I think we should probably do both of them, just because I think people's attitudes on birth control is really important to how they think about, sexual encounters and stuff. Whereas if they're really lackadaisical on birth control, well, then you're going to have a high risk of STIs and all that stuff. Whereas if you're really on point about birth control and your partners and everything, then you're probably a lot less likely.
Okay, that's true. Anybody else have thoughts about what scale we should use?
So when I was doing research for my scales, I came across this one article, and it has a lot of like information based upon, well, I mean, like actions, but there's also one section on attitudes, and it's specifically about condom use. So it kind of goes along the lines of like whether or not, like, how people would view someone like that's basically like that carries condoms or whatever. And so maybe like that could tie in with that.
So Courtney, were there specific questions? Did they have a scale?
Yeah.
Okay, I'm trying, and you sent that to me?
Yes.
Okay, let me pull it up really quick. I'm finding it. Because maybe that might be good, like the point that Jordan made about, if somebody, I think condom use is really a good thing to think about, because that can protect you not only from pregnancy, but from a lot of the STIs.
Yeah.
Um,
And like it's got like a different variety of like topics, I guess, that they use. So it includes questions on each one of them. And then they're ranked on a scale of 1 never, 2 sometimes, 3 often, and 4 always.
okay, so we could do that. I'm trying to find, Courtney, would you be willing to pull out the questions that they did on condoms?
Yeah.
And like, just like type them up for me and send them to me?
Okay.
Okay, so would you guys be good with that if maybe we did the permissiveness scale and then the condom usage? What do you guys think about that? Or maybe we do the condom usage and the birth control thing, because those questions were on a Likert scale too. So maybe we add those together to make a scale for birth control. Does that sound good? Okay, so Courtney, send me those. And so what I'll do is I can put that together. I can put together the 2 scales we're gonna do, and I'll send it out to you guys to look at it. And then hopefully we can get that finalized before the beginning of the week, next week. And I'll have the survey link that you can then send out to people. however you want. I mean, like I said, last summer I had some people just put it on social media and just said, you know, if you're between the ages. So I'm assuming we talked about doing kind of a broad scale, 18 to, what did we decide?
Wasn't it 18 to 30?
Yeah, 18 to 30. Are you guys good with that? So just say if you're between the ages of 18 and 30, this is a survey we're doing for my statistics class. It's anonymous. If you'd be willing to fill it out, it's on, you know, sexuality education. And then, you know, if you just put it out there, then hopefully I mean, last summer we got like 120 people, and we had 9 or 10 people in the class too. So we did get quite a number of people to fill it out. Okay, so I really want to make sure we get at least 60 or 70, but if we can get like over 100, that helps with, if we have a lot of data, it helps us have enough enough strength or power in the data that we could actually see if there's some differences.
I do have a question. I know this would probably be too like in depth, but how would the birth control portion of it affect like the LGBTQ plus, I think I said the acronym right, community?
Well,
because they don't like the males have to wear condoms.
Yeah, condom use can still definitely be a factor, or barrier, some kind of barrier can be a factor, because you can still use, even women can use dental dams, you know, they can use barrier protection. So yeah, I mean, that's definitely a factor, but remember, we've got to try to keep it as simple as possible, because like there's so many factors for us to look at, and those are things that we write up in the lab. We can say, you know, there's a lot of things we didn't ask that could have affected our data, right?
Okay.
We didn't ask about orientation. We didn't ask about whether somebody was married or not, or whether they had a regular partner in a monogamous relationship. You know, we didn't ask those kinds of questions. So those are things that can introduce bias and error. Mm-hmm. So we just have to admit that stuff right up front, right?
Okay.
There could be a lot of error in this because of these factors. So no matter what research you do, you're going to have error. You know, you can't ask or get every piece of information, or even if you're doing something with physical, like where you're doing something about diet, or you're doing something about weight loss, or you're doing something about people taking meds, or you're doing something, you know, about clean water. There's going to be tons of other factors that enter in that we might not be able to measure. And we always have to just be willing to say, there's going to be error in these. These are possible areas that could have created error. So like in your lab write-up, you're going to say that, you know, that these are possible areas that we didn't measure. And those are good things to bring up. You know, there can be, you know, the fact that Sierra did the article about autistic individuals, you know, just even people's cognitive ability can affect their risks, you know, their sexual risks. So we definitely have to bring those up as issues that could create bias. Okay? Okay, so are you guys feeling okay about that, everyone? Okay, awesome. So now we're getting we're getting to the place where I can get that kind of together, and we can start moving on that for next week. Okay, because what we're going to do is get some data collected, and then we can start talking about, oh, how are we going to analyze this? And then what are you going to do with this? We're going to, because you could analyze it in a lot of different ways. So we'll talk about how could you analyze it, and then you're going to be writing up a short lab report, you know, a 2 to 3 page lab report with a hypothesis, with a how we collected the data, so the methodology, your outcomes for your data analysis, and then your conclusions. Okay, so we'll be talking more about that next week, about how you would do that. Okay, so you guys feeling good about that, about the project? I'm feeling really good about it. I think we're on, you know, we're in a good place. So you guys got some articles, because you're going to need to maybe cite some articles. So make sure that you have at least 1 or 2 articles, 3 articles that you can cite about sexuality education, about sexual attitudes. Feel free, and in fact, I might make a place, maybe I should make a place on, let's do this, let's make a place on Blackboard. I'll make a place on Blackboard where you guys can share your research, the URLs that you found. And this will be a good place for everybody to post, and that way you guys can look at each other's research. So anything you find about sexual attitudes, scales, sexuality education, if you can post the URL on, I'll make a place on Blackboard and I'll share that with you where you can share that, like a discussion. I'll do a discussion on the project. And that way you can share it with each other, because you need to cite some of those in your lab report. Okay? Okay, so let's move on. We're going to finish up our lecture 5. But before we do that, any questions? Did anybody have any questions about 4, about homework 4 or quiz 4? Oh, let's don't do that yet, because we have some people that haven't done it yet. I've got a few people that didn't get it done because they didn't have the tool pack. So I'm gonna, let's wait on that, and we can do that tomorrow, okay? If you didn't get, I think everybody might have got their stuff done except Nicole. Courtney, did you get your homework done? Okay, so let's wait till tomorrow. So Nicole, if you can try to get that homework done by the end of the day, that would be really good. That way we can have some discussion on that. Okay? Okay, thank you. Okay, so let's go ahead and move to the lecture. Okay, so I've got the lecture up. I want to keep my chat up. So can you guys see the lecture? Okay, so we're on the lecture, chapter 5. I'm just going to quickly go back through what we did yesterday and see if you guys have any questions. We talked about scales of measurement. So nominal being just categories, just labels. Remember that this most connects with mode. So the most commonly occurring data. So remember, nominal cannot be analyzed with statistical inferential statistics. So we don't do means, median, we don't do means on nominal data, okay? We don't do a t-test or any kind of inferential statistics, okay? There are some statistics you can do, but they're special, like you can do something called a chi-square with nominal data, but we're not going to do that in this class, okay? So nominal data is just used to divide groups up. So like we're going to ask them, did you have good sexuality education? Did you not have good sexuality education? That's just a label, right? Yes, we're going to describe, this is what good sexuality education looks like. Did you have that? If you didn't, then you're a no. Okay, that's just categorical. Okay. Ordinal data, that's just ranked data. It's just put in order from first to last. Okay. This also cannot be, you can't do averages on this. Okay, because it's just ordered. So the best measure of central tendency for this is the median. Okay, so the median relates to ordinal data, just the middle, just finding out where's the middle of the data that I collected, okay? And then continuous data, this is where we can actually take data and we can add, subtract, multiply, divide, okay? So we can actually manipulate this data because it has equal distance between each unit, and sometimes it has a true 0 point. So when we have ratio data, we can actually do rates with this, okay? But interval data, we can also add, subtract, multiply, divide, okay? So if it's continuous, this is quantitative data with equal distance between each unit, okay? So this is the data we're going to be using to do statistical evaluation of, okay? And the mean is the most meaningful measure of central tendency or of variance, okay? So mode, median, mean, okay? That's how they relate, okay? So then we did then talk about how if you have a variety of data, you can order that data. This is continuous data, and you can find all kinds of descriptive statistics on it. The mean, the standard error, the median, the mode, the standard deviation, variance, kurtosis, skewness, range, the minimum, the maximum. So we can do all of this. These are all descriptive statistics because this data is continuous. We can actually find the mean on it. So the mean is actually the mean and the standard deviation. Those are the most meaningful for this data because it's continuous, okay? And then we can see how that falls onto a normal curve, a Gaussian distribution. How is this data distributed? So Excel will actually plot this data, and this array of data actually is normally distributed, okay? So let's say this was a random sample from a population. We can find that it was actually normally distributed, okay? So we can measure that with Excel. So we talked about the normal curve and how you really need to know all the characteristics of the normal curve. When you have randomized data samples, they tend to fall into a normal distribution, okay? And so when we pull things onto a normal distribution, we talked about how there's 3 standard deviations, and how 68% of the data falls within the first standard deviation, 95% of the data falls within the second standard deviation, and 99% of the data falls within the third standard deviation, okay? You need to just know that. You got to just memorize that normal curve, okay? The reason we do that is because we can use that to determine unusual events or differences between groups. This is the whole basis of probability and statistical analysis, okay? So if our data, if the measurements fall 2 standard deviations apart, we know that they're considered different. So if we have a sample mean that's 2 standard deviations away from another sample mean, we know that those 2 samples are different. They come from different populations, okay? We can do this also with raw data. If we know 2 raw data points fall 2 standard deviations apart, so if we see a raw data point and it falls outside of 2 standard deviations, we can say that person, that data is different. It comes from a different population. They are statistically different, okay? So we can find differences between an individual event, but we can find differences between groups, okay? We also talked about some of the denotations that you'll see. The small x is the raw score, a subject score. The n is the number of subjects. The large M is a mean score, okay? The small s is a standard deviation. Variance is the square, of the standard deviation. So you'll take a square root of the variance to find the standard deviation. And then today we're going to talk more about z-scores and t-scores. But z-scores, basically you're standardizing the score. So if we have 2 groups, we're going to standardize the score into a z-score so we can compare it. Okay, so we talked about the mean, the median, and the mode. Okay, the range. And then we actually got into calculating standard deviation, where we took each individual raw score. We took a raw score, we subtracted the mean to get a difference. And sometimes that difference is negative because you'll have some scores that fall below the mean. Half the scores fall below the mean, half the scores fall above the mean. So some scores are negative, so we have to square that because we don't want to deal with negative scores. Okay, so we square that. Then we sum those squares up to get the sum of the squares. We divide that by n minus 1 to get the variance. So s squared is the variance. And then we want to take the square root back out because we want to get that square root back out, that square back out. So we take the square root and that gives us a standard deviation. So you need to know how to calculate that. I will give you the formulas on the quizzes and the test. So the formula will be there, okay? But you have to know how to do it. Okay, so I'll have the formula. So I'll have, this is the formula of variance, right? And then standard deviation is the square root of the variance. So you have to figure this up. And the biggest mistake people make is they don't take the square root. So don't forget to take the square root at the end. So once you figure up the variance, then you have to take the square root of the variance to get the standard deviation. So like I said, I will have the equations there, but you have to be able to do that. So like on the quiz, there'll be I'll give you a group of numbers. So there might be 5 or 8 numbers. You're going to have to figure out the standard deviation by hand. Okay. So you need to figure that up by hand. So you need to go through and actually do the raw score minus the mean, and then square those, sum those up, divide by n minus 1, and then take the square root. And that will give you the standard deviation. Okay? So you need to go in and actually practice, go back through this outline, do this on your own, actually do it by hand so you know like, okay, that's how to do it. Okay? So you're going to have to do that on the quizzes and on the test. Okay? So that's the standard deviation. And then we talked about z-scores, standardizing a raw score. So you can have a raw score from 2 different groups. You could standardize those, put them on the z-scale, and be able to compare them. And the way we figure up a z-score is to take the raw score minus the mean and divide by the standard deviation. Okay, take the raw score, subtract the mean, and divide by standard deviation. This gives us a z-score that we can then plot on the z-scale. Okay, once we can do that, we can figure out what the percentile is. Okay, using that percentile chart that I sent you the link for yesterday. So you're going to have to be able to do that on the quiz and the exam. I'll give you a raw score and a mean and a standard deviation. You're going to have to be able to calculate this and then tell me what percentile it falls at. Okay? And then the t-scores are basically the same thing as a z-score, but what it does is it actually translates it into all positive scores. Because some people hate remember we figured up yesterday and we got like negative 0.4375, and some people just hate all of those decimal points and negatives. So some statistician many years ago said, let's do a new scale called the t-scale. The bad thing about the t-scale is you still have to figure out the z-score, because the t-score uses the z, okay, and all it does is it takes the z-score, multiplies it by 10, and adds 50. And that's your t-scale. So the t-score, you have to figure out the z, you multiply the z-score times 10 and you add 50. And on the t-scale, the mean is 50 and the standard deviation is 10, instead of the mean being 0 and the standard deviation being 1, which is the z-score. The z-score is where the mean is 0 and the standard deviation is 1. Okay, so I'm going to do some more examples. What do you guys think? You want some more examples? Yeah? You want me to do another example? Okay, so let me go back in here and do a new screen share. Okay, so I'm gonna do a screen share on screen 1 for the whiteboard. Okay. Okay, can you guys see the whiteboard? No, what are you seeing?
The lecture still.
Yeah, the lecture's still up.
You're still seeing the lecture. Okay, hang on. Let me try this. Okay, can you see the whiteboard now? Okay. Okay, so let's start with the normal curve. So you guys should be able to just draw the normal curve. Like if I just ask you, can you draw the normal curve with the z-scale and all the characteristics of the normal curve? You should be able to do this. So you just be able to draw a normal curve. This is the mean, okay? That's where the mean is. Standard deviation 1, 2, and 3. Standard deviation 1, 2, and 3, okay? The z-scale, the mean is 0. And then the first standard deviation, so each standard deviation is 1. So it has a mean of 0 and a standard deviation of 1. So 1, 2, 3, okay? Standard deviation of 1, -1, -2, -3, okay? So the z-scale has a standard deviation of 0 and a mean of 0, because this is where the mean is. And then the standard deviation of 1, 1, 2, 3. You guys see that? -1, -2, -3, okay? So the percentages, the first standard deviation is 34% for each standard deviation, right? And then the second standard deviation is 13.5, right? 13.5. And then the next standard deviation is 2.4, 2.4, and then basically 0.1, 0.1. Yeah, are you with me? Okay, so the first standard deviation is 68% of the scores. The second standard deviation is 95% of the scores. Oh, I'm losing my 95. And then the third standard deviation is 99% of the scores. Okay, so if you added all of these percentages up, it would get to 99. If you added these percentages up, it would get to 95. And then you add these percentages up at 68. Okay, is everybody seeing that? Everybody feel good about that? Understand what that is, how that works? Okay, so this is the time. Don't feel bad if you're feeling unclear at all about that. This is the time to say, I don't understand this. Okay, so this is, this holds all of the data, this normal curve, okay, whether it's a sample or a population, okay? So we're going to be concentrating on the first 2 standard deviation in social science, in exercise science, in most health science research, they're using the 95th percentile, okay? So we're saying anything outside the 95th percentile, either below or above, is considered unusual. It's not part of this same group, okay? Some medical research will use the 99th percentile because if they make a mistake, someone could die, okay? So some medical research will say we have to be 99% confident, okay? But a lot of research, they'll say 95% confidence level is acceptable, okay? So in this class, we're gonna use the 95th percent confidence level. So 95% of the data, we're gonna say, if it's outside of that, we feel confident that it's different, okay? Are you guys feeling good about that? That concept, you can understand that concept? Okay, good. Okay, so we can actually then we can put data onto this scale if we know means and standard deviations. So if we have an array of continuous data, we can do descriptive statistics and we can find out what's the mean and what's the standard deviation. So we can get some context to the data, okay? So for instance, if I tell you, so for this first test, if I tell you, oh, you got a 75 on the test, okay? If I just tell you your raw score, it's kind of meaningless until you know what the standard deviation is and what the mean was. Okay, so I could tell you you got a 75 and you might be like, what? That's horrible, because in your mind, you're thinking it's on a 100-point scale and you're thinking a 75 is a C. Or what if I told you you got a 60? You'd be like, what? But then what if I told you that the average was a 50, right? Then all of a sudden you're like, oh, wait, maybe it's not so bad, okay? So you've got to have context. Okay, so let's say that you took a test and you find out that your the mean of the test was equal to 52 and the standard deviation was equal to 5. Okay, so now we have some context on a raw score. Okay, so if you tell me that your raw score on the test was a 68, I'm sorry, this was the mean, right? That was the mean. So if you tell me your raw score, your score, let me go back, since I had told you that the mean was a large M. Okay, so the mean was a 52. So your raw score, what did I say, was a 68? Okay, so now we can plot that, okay? We can say the mean was a 52. I'm just gonna use my finger. The mean was a 52, and then we know the standard deviation was 5. So we can actually plot those scores. So that'd be a 57, then we'd add 5 more, that'd be a 62, then we'd add more, that'd be a 67, okay? Then we go the other way. We subtract. 52 minus 5 is a 47, then minus 5 more is a 42, then minus 5 more is a 37. Okay, are you guys with me? Yeah? So this means that 95% of the scores on that test fell between 42 and 62. Okay? Are you seeing that? Okay, and 99% of the scores fell between 37 and 67. Okay? So now I can actually plot my score. You know, I could plot it on here easily, just by, you know, this is a 67, then here's my score right here, 68. Okay, but I can also convert this into a z-score. So the z is equal to the raw score minus the mean divided by the standard deviation. So if I get my trusty calculator, let me turn my lamp on. So if I get my trusty calculator, I can say 68 minus 52 equals 16, divided by 5 equals 3.2. Okay, so 1, 2, 3.2. So that's where my score falls, 3.2. Okay, so how did I do on the test? How did I do?
Better than 99%?
Yes, exactly. So I'm above the 99th percentile. In fact, I'm probably a way better achiever than the rest of the class, right? I'm unusual. My score is unusual because 95% of the class scored between a 42 and a 62. I got a 68. So I'm unusual. I'm outside, right? Make sense? Okay. So I'm able to do that. But let's say now we're taking the final. And I find out that on the final, the mean was 71 and the standard deviation was 10. Okay, so now I can plot the raw scores: 71, 81, 91, 101, 61, 51, 41. Okay, so now I know that 95% of the people scored between a 51 and a 91. Okay, and let's say that my score on the final was a 80. Okay, so I know that I scored like right around in here. Okay, but I can go ahead, I'm going to do my z-score. So my z-score is an 80, whoops, an 80 minus 71 over 10. So what's my z-score? I take the raw score of 80, I subtract the mean of 71, and I divide by the standard deviation of 10.
0.9.
And I get 0.9. So there I am. Here's my standard deviation of the z-scale. I'm right below 1, so I'm right here. So this is where I scored on the final, and this is where I scored on the midterm, say. So I did much better on the midterm than I did on the final, right? So I could even kind of guess what my percentile was. Like Sierra shared with us, I was above the 99th percentile. So Sierra, where would I be on my final? If you just had to guess without looking at the table. Can you kind of guess what my percentile was? What would my percentile be if
Wouldn't it just be in the 68th percentile?
Well, I'm right here, I'm at the 50th. I'm almost at the first, so I could take 50 and I could add 34. Are you seeing that?
So then you'd be in the 84?
Say it again.
84?
Yeah, so around 82, 80, 82, right? Because it's a little bit before I hit this. Let's say my z-score was 1.0. I know I'm right at the 84th percentile, right? Because 50 is here. And then if I add this other 34%, because if I'm right here at the first, that would be 84. Are you guys seeing that? It's really important that you see half of the normal curve is 50%. Yeah, are you guys seeing that? There's 50% of the scores below the mean. There's 50% of the scores above the mean. Yeah? So if your z-score was 0, what would your percentile be? Jordan, what would
50th.
that be?
50th percentile.
Exactly. Okay, so if your z-score is 0, you're going to be at the 50th percentile. Okay, and then if your z-score was 1, you're going to be at the 50 plus 34%, so you're going to be at the 84th percentile. And then if I had a z-score of 2, I would add 13.5% more, so I'd be at the 97.5 percentile. Is that making sense? Okay, if I was at -1 z-score, I could take 50 minus 34. So I would start at 50, I would subtract the 34 because if I'm here, then I would subtract 34 and I would get the 16th percentile, right? 50 minus 34 is 16, right? Are you guys seeing that? So I could go this way. I could add 2.5 to 13.5 and I would get 16. So if my z-score was -1, that means I'm at the 16th percentile. Do you guys see that? Everybody?
So for the z-scores, like you really don't, like I know all the data is still like in the 68, 95, but you don't use those to like calculate the percentile? Like those are
Well,
just...
this gives you information about what percentage of the data is in that area, right?
Okay.
So 34% of the data is right here in this area, right?
Mm-hmm.
And 13.5% of the data is right here in this area. So if my z-score falls right here, I've got this, and then I know 2.4% is in this area, so I would add 13.5 and 2.4, and then I know 0.1% is down here in this area. I would add 0.1 more. So if I added 0.1, 2.4, and 13.5, that all adds up to 16. So I would be at the 16th percentile if my z-score was -1. Yeah, can you guys see that? If my z-score was 0, I would be at the 50th percentile because then I would add another 34% that I'm above. Okay, so like if I tell you, like say you calculate on the quiz, let's say you calculate your z-score and you get a z-score of like 1.2. Let's say your z-score is 1.2. Okay, and then the answers that I give you for percentile to choose from, let's say I give you the 7th percentile and I give you the 41st percentile, and then I give you the 87th percentile. Which one is it probably? If your z-score is 1.2, 1.2, there's your score right there. Is that the 7th percentile?
It's the 87th.
Yeah, the 7th percentile is down here, right? 0.1, 2.4, the 7th percentile would be right in here, okay? The 41st percentile would be somewhere, we know 16th is right here, it'd be right here. So it's gotta be the 87th. In fact, if you have a positive z-score, you know the percentile has to be above 50, right? Because if it's positive, it's above 0. So it's got to be above the 50th percentile, right? If it's a negative, you know it's below 50. If you have a negative z-score, your percentile has to be below 50. If you have a positive z-score, you know your percentile has to be above 50. Are you guys seeing that conceptually? Okay, it's really important that you see that conceptually because it really helps you to understand the whole idea of percentiles and why we use z-scores or t-scores. Okay, are you feeling good about that? Feeling okay about that? Okay, so then I just mentioned t-scores. We could even convert, like we just got a z-score here, which I didn't write it down. So what was this? This z-score was 3.2, I think, right? If we go back to this z-score was equal to 3.2. And this z-score over here was equal to
0.9.
0.9. Okay, so let me just erase that so I'm not confusing anybody. Okay, so so this z-score was, oh, come on, let me draw. Okay, was 0.9. 0.9. Okay, so now I can convert these into t-scores. Okay, all I have to do to get the t is I take the z-score of 0.9, I multiply that by 10, and then I add 50. Okay, so if I do 0.9 times 10, that's 9, right? And then I add 50, so that'd be 59. And on the t-scale, does anyone remember what the mean was? Jordan, were you going to say something?
I
So
thought it was 58, but I might be wrong.
what'd you say, 50? Yeah, so on the z-scale, the mean is 0. On the t-scale, the mean is 50. And the standard deviation is 10. So you can see this. It's multiplied by, you add the mean and you multiply by the standard deviation, okay? So if we do this, that's 59. So a z-score of 0.9 is a t-score of 59. It's the same place, right? If this is 50, and this is 60, 70, 80, because the standard deviation is 10. Okay, do you guys get that? So let me get rid of some of this stuff. Okay, so this is the z-scale. The t-scale, the mean would be 50, and the standard deviation is 10. So you would add 10, 60, add 10, 70, add 10, 80. Subtract 10, 40, subtract 10, 30, subtract 10, 20. Okay, so if I've got a z-score of 0.9 right here, then I can convert to a t and it's 59. 59, it's in the exact same place. It's just a different way to express it in a positive number instead of 0.9. No decimals, no negatives. Okay, I'm gonna stick with z-scores because to get a t-score, you have to figure up the z-score anyway. Negatives don't bother me, decimal points don't bother me. So we're gonna be using z-scores, but I need you to know that t-scores are used sometimes. It's a capital T, and it has a mean of 50 and a standard deviation of 10. That's really all you have to remember, is that it's a conversion of a z-score and it has a mean of 50 and a standard deviation of 10. okay? And the z-scores have a mean of 0 and a standard deviation of 1. Okay? Questions about that? Anybody? Questions? Okay. So now I'm going to hop back to our lecture. Okay. So covered all of that. Okay. So now these last three, four concepts. I know I've been throwing a lot of stuff at you, but I'm going to jump to the next level. Okay. So the whole reason we're doing stats is to figure out probabilities to see if scores or means are different enough for us to say they come from different populations. So if I have means from samples, I can say they're different, okay? So for raw scores, to see if two raw scores are different, we're using standard deviation. So if the standard deviations can tell us, hey, if this score falls outside of 2 standard deviations, it's considered different. Okay, we've already talked about that concept. So remember, we had, like, if you scored the 68 on your midterm, it gave us a z-score of 3.2. You were outside the 2nd standard deviation. You were actually outside the 3rd standard deviation. Okay, so that's for raw scores, raw individual scores. But now when we look at the characteristic of sample means, we're going to be figuring up means of different sample groups, okay? That's the only way we can say if populations are different. Okay, so what we're doing is we're looking at sample means to see a range of values of means, okay? So it's not raw scores, now we're looking at means. Okay, so now, here's this idea. Let's say we have a large population, say CSU Pueblo students. So we've got 4,000 people in our population, okay? We're gonna draw a sample, yeah? Because we're not gonna measure every, let's say we wanna look at, let's say we wanna look at sexual attitudes. We've been talking about sexual attitudes. So let's say we want to look at sexual attitudes about condom use, okay? So we have this scale where we're measuring condom use and we're getting a number about sexual attitudes about condoms, okay? So we've got the whole CSU Pueblo population. Well, we can't measure, we're not going to measure every single student. So we're going to take a sample, yeah? Okay, so we want to take a random sample of the students and we want to measure their sexual attitudes. Okay, so if we take one sample, we're going to get one sample mean. Yeah? Make sense? So let's say we take one sample of 100 CSU Pueblo students. We're going to get one sample mean. Okay, but what we can do, and let's say we just take one sample of 100, could there be some error in that? Absolutely. If we're only measuring 100 out of 4,000 students, we could end up with some error, okay? So what we can do is we can take, in order to find out what the standard error might be, we could, and let me go back and share my, I'm going to share the whiteboard again. Okay, so can you guys see the whiteboard? Okay, so I'm gonna clear everything. Okay, so we could go back and in this example, oh, that was crummy. Let me try again. Okay, so let's say that we draw one sample. So we draw a sample of 100. And we find out that the mean for that 100 people, let's say the scale goes from 1 to 20. Okay, I'm just making all this up. Okay, but the mean for that group was a 15. Okay, or yeah, 15. And then let's say we draw another random sample of 100, and their mean was 15.5. And then we draw another 100, and their mean was 14.7. And then we draw another 100, and their mean was 14.9. And then we draw another 100, and their mean was 15.6. Wait, 1, 2, 3, 4, 5. Okay, so let's just say we did 5 samples. We could do 10 or 20 or 30, okay? And then now we have a distribution of means. Okay, are you seeing that? So we end up with 5 samples, and we're gonna find all of their means, and now we're gonna compare, they're gonna find the standard deviation of those means. Okay, can you see that? We can take those means and we can find basically the standard deviation of the means. Are you with me? Because there's going to be variability. There's always variability. If I ended up drawing 10 different samples, are their means always going to be the same? No, because it could be 100 different people every time. So there's always error. If I'm drawing a sample, there's going to be maybe a little difference from the actual population. Let's say somehow I did measure every single person at CSU Pueblo, and I found the parameter. Okay, so the parameter mean, it's like an alpha level. Let's say the parameter mean, the actual mean of the population was, let's say, 15.3. Okay, so let's say somehow I knew that. So I know the real mean, the true mean of the whole population was 15.3. This is a parameter. But I've drawn all these samples. These are statistics. Okay, these are samples, and these are statistics. So I could draw 10 samples or 20 samples, and I would get a distribution of means, because I know that they're not always going to be exactly the same because it's just 100 people. This is 4,000 people. Okay, are you with me? So I can get the mean of the means. I can actually come up with a mean of the means. Yeah, so I could take all 5 of these, and I could find out that I can add them. So I can find out 15 plus 15.5 plus 14.7 plus 14.9 plus 15.6. I just screwed up. 15 plus 15.5 plus 14.7 plus 14.9 plus 15.6 divided by 5. So I find out the mean of the means. So the mean of the means is equal to 15.14. Okay? And then I can find the standard deviation, right? So I could find the standard deviation of the means, and that is actually called the standard error. Okay, so the error is that deviation that happens. So here's the error, the difference between 15 and 15.3, the difference between 15.5 and 15.3, right? We know there's a little bit of difference in every sample that we pull. That's the error, right? That's how this sample is deviating from the true mean of the whole population. Most of the time we don't know that. That's why we're using a sample. But in order for us to find out the standard error, we would actually have to do this research. Okay, so there's some things like body fat, like doing skin fold analysis. We know what the standard error is because someone did the research. Okay, they had a whole group of people. They found out their body fat, their true body fat, using like hydrostatic weighing or bod pod, and then they went in and drew samples and did their body fat with skin folds. And then they found the mean of the means, and they figured out the standard error. Okay, which is basically the standard deviation of the means. Okay, and then you can just plot it. Okay, so in order to figure out the standard error of the means, that is the square root. It's on your lecture. It's the standard deviation of the means divided by the square root of n. Okay, so this would be, we'd have to find the standard deviation, which we could find if we figured it out. But the standard error is equal to the standard deviation divided by the square root of n, which in this case would be 4. And then we would take the square root, so it would be 2. So we would take whatever the standard deviation is of this, I'd have to figure it up, and then we divide it by 2, and that would give us the standard error. Now, I'm going to be giving you the standard error, I think. I'm trying to remember. I pretty much usually give you the standard error. I don't make you figure it up by hand. I am going to make you figure up some standard deviations by hand. And then once you know the standard deviation, it's really easy. You just take the standard deviation, divide it by the square root of the number of subjects. Okay? Actually, this isn't 4. This isn't n minus 1. It's actually n, so it'd be the square root of 5. Okay, so then I can plot that. Okay, then I can plot that. So let's say my mean is 15.4, and let's say that my standard deviation, or do you guys want to figure that out? Do you want me to do an example of figuring standard deviation out by hand? What do you think? Jordan's saying yes. Okay, so if I wanted to find the standard deviation of this, okay, what I have to do is I have to take each raw score, which these are considered my raw scores now, and I'm going to take the raw score, 15. I'm going to subtract the mean, 15.14. So I'm going to take 15 minus 15.14, and that's negative 0.14. And I'm going to square that. So I've got to find my square on this. This calculator is like really, this is actually a complex calculator. It actually does statistical analysis, so I'm trying to find it. So this is going to be hard because I've got all these decimal points. I might not want to use this as an example because I want to use whole numbers. But what I would do is take this, square it, add up the sum of squares, okay, divide by n minus 1, and then take the square root of that. The nice thing is once we put this stuff into Excel, it figures it all up for us, okay? I'm going to make you do it with very simple numbers. I'm going to give you, a small group with easy things that don't have decimals, that aren't large numbers. They're going to be small. I just want you to be able to figure it out by hand. Okay, just so you can see that it looks at the raw score minus the mean, squares those, adds them up, divides by n minus 1, then takes the square root, okay, to get your standard deviation. So let's say I find out that my standard deviation of this array is equal to, it's going to be small, because see how close these are? It's going to be really small. So let's say it's, let's just say for the sake of just guessing, it's going to be around 0.25. Okay, so then what I could do is plot this very easily. So I could put 15.14, and then I could just add my 0.25. So 15.14 plus 0.25, my standard deviation. So it's going to be 15.39 for my first standard deviation, plus 0.25, 15.64. Okay, and I really just need the 2 standard deviations because we're going to stay in 95. Okay, then I could take my 15.14, I could subtract my 0.25, my first standard deviation, so 14.89, and then I subtract 0.25 again, and I get 14.64. Okay, so I know that 95% of my sample means should fall between 14.64 and 15.64. Okay, do you guys see that? It's the same thing we did before with the raw scores. With the raw scores, we just used the standard deviation. Actually, this should have been standard error. That's what I was trying to say. This would be, because it's a standard deviation of the means. So this is the standard error. And I'll be giving that to you. So with the raw scores, with raw scores, I'm going to use the mean and the standard deviation. So I'll use the mean here, and then I'll use standard deviation. Okay. But with means, I'm going to use the mean of the means and the standard error. But it's the same concept. Okay, so if I found, if I have a mean that falls between 14.64 and 15.64, I know it's part of that CSU Pueblo population. But let's say I had a sample group that had a mean of 15.8, and it fell out here. Then I know that that sample is different from the rest. It's statistically different because it fell outside the second standard deviation. Or let's say I had a mean that was 13.9 and it fell down here. I know now that sample is different from the rest of these samples. It falls outside the second standard deviation, so it's different. Okay, so on a quiz, if I'm asking you to look at raw scores, like if I say, here's an individual raw score from a person, you would use the mean of that group and the standard deviation in order to do the comparisons. Okay, but if I said, here's a sample mean, is it different from this other sample mean? You would use the mean of the means and the standard error. And I'm going to give you all that information. Okay, and I'll actually go through some examples. Okay, are you with me on that? Are you feeling okay about that? Yeah? No? Okay. Okay, so Do you want me to go through? Do you want me to give like a live example? Should I give an example like you might see on a quiz? Okay, so let's do that. Okay, so let's say that I tell you, okay, let's say I tell you you've got two groups of people. No, let's don't do that. Okay, let's say that I've got a classroom. Let me just go back to that example I was using with the lecture, with the quizzes, okay? So let's say that I tell you I've got quiz 1 and I've got quiz 2, okay? And I'm gonna tell you that in quiz 1, we have a mean of 50 and a standard deviation of 2. And in quiz 2, we have a mean of 70 and a standard deviation of 5. Okay? Are you guys okay with that? Okay. So now I'm going to tell you that I've got a raw score. I've got a raw score on quiz 1 of 61. Okay. And on quiz 2, I've got a raw score of 87. Okay. So now what I want you to do is I want you to figure up what is the z-score for that raw score of 61 on quiz 1. So what would be the z-score? Remember, the z is figured up by taking the raw score, subtracting the mean, and dividing by the standard deviation. So go ahead and figure that up. What's the z-score of this score? Anybody?
Is it 5.5?
Okay, so I didn't figure it up. So you would take 61, you would subtract 50, and then you would divide by 2, so 5.5. Thank you, Jordan. Okay, now figure up the z-score of 87 on this side.
$3.4.
So yeah, so 87 minus 70 divided by 5, 3.4. Wait, that can't be right. Raw score. Oh yeah, I gave too high a scores. Let's change this score. Let's make this 41. So let's redo that. I usually go through these, like the stuff on the quizzes works out because I make it so it's reasonable. So what's this one? 41 minus 50.
Negative 4.5.
No, that's still not good. Let's make it 51.
0.5.
0.5, okay? So that's good. Okay, so what did I say? This was 51. Okay, so I've got a z-score of 0.5 on this first one and a z-score of 3.4 on this one. Okay, so now we can compare that. We could compare that on the normal curve, right? Okay, so we've got 3.4. This score is way over here, and we've got a 0.5, and this score is right here. Okay, so for this one person in these raw scores, What did they score better on, quiz 1 or quiz 2?
Quiz 2.
Quiz 2, absolutely. And were either of the scores unusual?
Quiz 2.
Yes, quiz 2 was unusual because it fell outside the second standard deviation. It was their z-score was higher than 2 or lower than -2. So if the z-score would have been higher than 2 above the second standard deviation or lower than 2 below the second standard deviation, it would have been considered unusual or different. Okay, so what I might ask you on a quiz is something like, figure these up, and then, you know, I might ask you which one did they score higher on, or I might ask you, you know, were any of these unusual? Or I might give you a score and say, like, I might give you some raw scores, and I might say, which one of these would be considered unusual? So you'd have to figure up the z-scores and be able to tell, is there a z-score above 2 or below -2 to know if it was unusual? Does that make sense? So that's what you would have to do. That's an example with individual raw scores. I might ask you if any of the scores are unusual, and I'll give you a group of scores. You know, I would say like in this example, I might give you an example of what would that be? So I might give you an example of 42, 48, and 51. And I would say, which one of these would be considered unusual? And you would figure out the z-scores. And so on 42, you would figure out the z-score of 42 is 42 minus 50 equals -8 divided by 2 equals, 42 minus 50 equals -8 divided by 2, right, is equal to -4. Well, I know that's way out here, right? So I know that's unusual. 48, so it'd be 48 minus 50 is 2, divided by 2 is 0. I'm sorry. Yeah. So I'm there, right? So I could figure out my z-scores for each one of these, and I would know to choose this as my unusual score on my quiz score. Yeah? Okay. But then if I'm doing, so let's say I'm doing something with, let's say I'm doing something with sample means. So I could give you some sample means. I could say I've got one sample with a mean of 100 and another sample with a mean of 104, right? And then I would show you the standard error is equal to 3 and the standard error is equal to 1. Okay, you do the same thing, right? I could give you one sample mean that was like, okay, well, here's a sample mean of 105, and here's a sample mean of 103. Okay. Then I would need you to do a comparison of those and tell me which one of those, or, you know, I could put them on the normal curve. Okay. And I could say, I could find those standard errors, and then I can find the z-score, and then I could plot those and I could say which one is unusual. Okay, so I've got those two means, or I could ask you if either one of those are unusual. So it's the same process as we just did. Okay, so it looks the same, it just takes it to the next level, because this is looking at sample means and we're using the standard error to find the range. Okay, so if I've got a mean of 100 here, and then I go, and the standard error of 3, this is 103, this is 106, this is 97, and this is 94, right? So I know that 95% of my means are going to fall between 94 and 106. Okay, so this was 105. So is this significantly different? Rachel Rummage, is that significantly different? No, because it falls within 106. It falls right here. It falls within the second standard deviation. This would not be considered different. So that means that this sample mean belongs in this group, this population. Okay, let's look at this one. If my mean was 104, right? And it was a standard deviation of 103, 102. Oh, I'm sorry, I'm going the wrong way. 105, 106, 103, 102. So is 103 significantly different? So did it fall outside the second standard deviation? Okay, remember we're looking at this group of data now. 104, 105, 106, because it had a standard deviation of 1. 103, 102. So does 103 fall outside the second standard deviation?
No.
No. So it also is not unusual. It would have had to be below 102 to be considered unusual, or above 106. Okay, so if I gave you, if I gave you a group of scores, if I said, here's your situation, let's say with this second group, and then I said, I didn't give you, I just gave you a like 101, 103, and 105. Which one of those would be considered different? 101, right, Jordan? Okay, so because 101 falls below the second standard deviation. So this sample mean, this sample is different from the population. Okay, so when we're talking about sample means, we're talking about, are those means different? Are they part of the same population? When we're talking about raw scores, we're talking about, do they come from a different sample, right? Raw scores, we're using standard deviations and we can compare. Sample means, we're saying, is that sample mean different? Or did they come from a different population? Okay, and really with statistics, we're primarily going to be looking at groups, not individuals. So we're really looking at the sample means, and the standard error is going to be really important for you to understand that concept of the probabilities. Okay, questions. It's a lot. I've thrown a ton of stuff at you guys. Anybody have questions? Okay.
So, I do have a question.
Yes.
So just to clarify, on that whiteboard, the SE is that the standard deviation or the standard error?
That's the standard error, which is basically the standard deviation of the means.
Okay.
You can think about it that way. It's like a standard variation measure.
Okay.
Okay. And when you do the descriptive statistics, you're going to see it'll give you the standard error and the standard deviation.
Mhm.
Okay. The standard error is what you're going to be using to compare it to other means of other samples. Okay.
Okay.
The standard deviation does give you context about how much the raw scores vary in the array of data. Okay, so it's still a very meaningful measure of variability, but the standard error is what's used to see if two groups are from different populations or they are significantly different. Okay? Anybody else? Clarifications? Okay, so now I need to take a few minutes to pull up the homework. Okay? The homework number 5. Okay, so let me pull up the practice homework. So the practice homework is in module 2, and you would just go to practice homework. Okay, so let me do a share screen. Okay. Okay, so you guys seeing practice homework 4 materials? Can you guys see that? Okay, so practice homework 4. So what I'm giving you is I've got a database that I've attached. So what you're going to be doing is you're going to assume the entire class is oh, I'm sorry, I should be on practice homework 5. Yeah, let me go back. I'm so sorry. Oh, here it is. Okay, practice homework 5. So what you're going to be doing is I've got the data sample for you. You're going to perform the calculation by hand so you can prepare for your midterm exam. And then you can use the descriptive stats formula in Excel to confirm your calculations. So I've got class height data for you. You're going to figure out the mean, the median, the mode, the range, the variance, and the standard deviation. Okay? Then you can run a descriptive statistics on the data so you can check your stuff by hand. And then you're going to generate a frequency polygon or a line graph or a bar graph from the distribution of scores by using the histogram analysis tool or the charting tool. Okay? And then you can calculate the z-score and the percentile of the score of 69. Okay, so those are all the things we're going to do. Okay, so then we can answer these questions. Okay, so let me pull the data up. Okay. So let me share the data. Okay. Well, my computer's being weird. It's not opening it. My computer's been doing so good. I hate this.
Mine opened it. I think I can screen share it.
Okay. Thing is, I have to give you, I think I have to give you permission
Yeah.
to share. Okay, hang on. Okay. Remember last time it was being weird and not like giving me the ability to do it either.
Yeah, I remember last time, I think you gave me control of your screen.
Yeah, which doesn't help. Let me try something different for opening my Excel. It had been working so great. Okay, let me try something different. Hang on. Let me just try going on to, because I've got my jump drive here and I should have it on my jump drive. So let me try that. Oh, I do have it. Okay. So I'm on homework 5, right? Okay. Yay, I did it. Okay, so does this look like the same data that you guys have? It's still that sample with the athlete and the area of residence, right? So same data. Rachel, is that the same as what you have? Okay, so what does it tell us to do? Oh, calculate the standard deviation, right? Yeah? Okay, so we can just do that by hand, but I'm gonna do it using I'm not gonna do every single thing by hand, but I'm gonna do it by hand in the cells. So the first thing I wanna do is I wanna subtract each, well, I wanna find the mean first, right? So how would I find the mean? Add all of these up, right?
And divide them by how many there are.
And divide by how many there are. Okay, this is kind of a lot of data to do. Whoops. So let's just do that first. Let's find the mean. So I'm going to find the average, and it's D4 through D47, so that's correct. So here's my average, 68.49. Okay? Make sense? So then I'm going to take each person, I'm going to take their raw score, so D4 is where the raw score is, and I'm going to subtract the mean, which is 68.9. Was it 68.9? 68.49. 68.49. Okay, so that's going to give me my difference, right? That's going to give me my raw score minus the mean, right? And then what do I do next? What do I do next? If I've got my raw score minus the mean, then I have to square that. Yeah? So how would I square that?
Just multiply it by itself.
Yeah, I can multiply it by itself. This is a lot for me to expect you guys to do by hand. I should give you a smaller array of data. Because I hate to make you guys do all this by hand. You know what I'm going to do? I'm going to give you guys another smaller array of data to do by hand. Okay? Because otherwise it's just going to take forever for us to do this. So I'll give you guys another smaller array of data to practice by hand. And I'll give you the answers just so you can see that you got the right answer, because you're going to have to do it on the quiz. So I'll give you something really similar to what you're going to have on the quiz. But let's go ahead and do the homework based on our descriptive statistics. Okay, so if I want to run descriptive statistics, I'm going to go to data. I'm going to do data analysis. And I'm going to go to descriptive statistics. Okay, so I'm going to run the descriptive statistics. I'm going to input my range. Okay, so I want to do heights because that's the only thing on here I can do descriptive statistics on, because this is categorical data. Whether they're an athlete or not is categorical data. Where they live is categorical data. The only thing that's continuous is height. And this is what we're looking at in this homework. So I'm going to do height. I'm not going to get my average. I don't want to do that because I only want the raw data. Okay. I had my label in the first row, and I want to keep this on the same worksheet. So I'm going to tell it to put it in to K1. And I want summary statistics. Okay. Okay, so here's all my descriptive statistics. My mean is there, my standard error is there, my median, my mode, my standard deviation, and then my variance. So like if I took the square root of 20.43591, it would be 4.52, right? Because standard deviation is a square root of the variance, okay? Kurtosis, this means how pointy or flat the curve is. So this means that because it's a negative, that means it's kind of a little flatter. The skewness tells whether the hump is kind of on one side to the other. So this has a tiny skew to it, a tiny positive skew, which means the hump's a little bit on the left side. It's got a range of 20. Okay, so the highest score was an 81. The highest height was an 81, and the lowest height was a 61. So it's got a range of 20, and there's 44 scores. Okay, so you seeing those descriptive statistics? Do they mean a little bit more to you than they did the first time you looked at them? Remember the first time we did this and you were like, what the heck is standard error? Well, now you know the standard error is that little bit of error that occurs due to the fact that this is just a sample, right? This is just a sample. This is not the actual population. So we have some error in this mean. Like this mean could vary. If we did 2 standard deviations, what do we have to do? We have to actually multiply this by 2, right? Do you understand what I'm saying? So let's go, in order to answer this, so I'm going to jot down the mean was 68.5 basically. and the standard deviation was 4.5, and the standard error was 0.68, right? Okay, are you with me? We've got all these things. Okay, we've got all these answers that we need. Okay, so now I'm going to go back. Let me go back to the homework and what it's asking. So now the homework is asking me, what is the range of scores for the distribution? So what was the range? Did you guys remember? Somebody, what was the range?
I think it was 20.
It was 20. Okay, and how do you figure the range up? Anybody? How would you figure the range?
You just minus the minimum from the maximum.
Exactly. So you take the highest score and you subtract the lowest score. So we know the highest score was 81, the lowest score was 61, the range is 20. So the range of the distribution was 20. Okay. Is this distribution in the scores normal? Does it fall on the normal range? Oh, we didn't do the histogram. I'll go back and do that. But I can tell you that the skew was only 0.3, which means that you pretty much know it's going to be fairly normalized. But I'll show you how to do the histogram. Okay. So now we can figure out what's the z-score of a subject who is 69 inches. Okay, so we want the z-score of somebody that's 69 inches. Okay, so let me go back. Let me go back to the whiteboard. Okay, so let me get rid of. Okay, so we know that on this, our mean was 68.5. Our standard deviation was 4.5, and our standard error was 0.68. Okay, so if I had a raw score of 69, so I have a raw score of 69, what's the z-score? Okay, so for the z-score, you're going to take your raw score, you're going to subtract, what do you subtract?
The mean.
The mean of 68.5, right? And then we're going to divide by what?
Standard deviation.
The standard deviation of 4.5. So what's that z-score?
0.11.
0.11, okay? So if I look at the normal curve, and I know that the mean of a z-score is 0 and the standard deviation is 1, where would 0.11 fall? Right above 0, right?
Mhm.
Right here. Okay, 0.11. So then I can figure out the percentile. If I just had to guess, what do you think the percentile is of a z-score of 0.11? If you just had to guess. Anyone willing to take a stab at it?
Like the 60th percentile?
Maybe somewhere between 50 and 60 probably, right? Because we know that right, 0 is 50th. So 0.1, somewhere between 50 and 60. So okay, so let's let's just go and look. Okay, so let me, I got it up. So let me now share the Z table. Okay, can you see the Z table? Okay, so if I go to 0.11, it's at about the 54th percentile. Okay, do you see that? So we know that this is the 50th percentile. And we know, and here's the first standard deviation, the second standard deviation, the third. So we know 0.11 falls right in here. So we know it's 50, and then that 0.1 ended up being about 4% more. Okay? Are you seeing that? So we're able to say a raw score of 69. Let me go back to a raw score of 69 gives us a Z of 0.11 and a percentile of 54, it was like 54.4%. Okay? Sound good? Okay, so that would be the answer to that. So let's see, what's the next question? So the next question is, what range of scores would contain 95% of all scores in the distribution? Okay, what percent of scores would contain 95%? Okay, so are you still seeing the whiteboard? Okay, so again, we had the mean of 68.5 and the standard deviation of 4.5. So if we do a normal curve, all we have to do to get 95%, remember, 2 standard deviations is 95%. Okay, so all we'd have to do is put our mean of 68.5, and then what do we do to find out the first standard deviation? What goes here? What would we do, Courtney?
89.5.
Well, what are we adding to 68.5 to get the first standard deviation?
Or 4.5.
The 4.5, right? So we would do the 68.5 plus the 4.5, 73. Okay, so this would be 73. And then we'd add it again, plus 4.5 would be 77.5. Okay, you guys seeing that? And then we would take the 68.5 and we would subtract 68.5 minus 4.5 equals 64. And then we would subtract 4.5 again, and we would get 59.5. So 95% of the scores fall between 59.5 and 77.5. Do you see that? So that's the range of scores. So if you had a raw score that was above 77.5, it's unusual. If you had a raw score that fell below 59.5, it's unusual. Okay, so that's the range of scores. It basically is the mean. It's the mean plus or minus 2 times the standard deviation, right? because the standard deviation once and twice. The standard deviation once and twice. So I could take 68.5, and I could add 2 times the standard deviation, I could add 9, and I could take 68.5, and I could subtract 2 times the standard deviation of 9. So 68.5 plus 9 is 77.5, and 68.5 minus 9 is 59.5. So the range is the mean plus or minus 2 times the standard deviation. Do you see that? So that's the range of scores for 95% of the scores. So when it asks, what is the range of scores for 95% of all the scores in the distribution? That's how you figure it up. You can draw it out. If you're visual, I would just draw it out. Just have a piece of paper, draw your normal curve, put your mean, add the standard deviation once, add the standard deviation twice, subtract the mean, add the standard deviation once, and then subtract it again. Then you'll see your range. Or you can just plus or minus 2 times the standard deviation, and that will give you your range for your distribution. Okay? Questions about that? Okay, and then it would ask you what height score of a given person would be considered unusual. What height score would be considered unusual? Well, anything above 77.5 or anything below 59.5. So like on the quiz or on the test, I'll give you a range of scores. I'll give you a bunch of different scores, and then you'll have to tell me which one's unusual. And the way you know that is by figuring out that distribution, and then you know that anything above 77.5 is unusual or anything below 59.5 is unusual because it's outside the second standard deviation. Okay? And then for your homework, it's also going to ask you what sample mean would be considered unusual. What sample mean would be considered unusual. So the way we do that, okay, the way we do that is we go back and we know that the mean again is 68.5, right? But we know the standard error is what we're going to look at for sample means. The standard error is 0.68. Okay? So then I could put that on a normal curve. Okay? And I'm going to have 68.5 here. And then what am I going to add or subtract now? The standard error. So when I'm looking at sample means, I will use standard error. So I would take 68.5 and I would add 0.68. So I would get 69.18, and then I would add 0.68 again, and I would get 69.86. Then I would subtract it, 68.5 minus 0.68, and I would get 67.82, and then I would subtract 0.68 again, and I would get 67.14. So I would know anything below 67.14, any mean below 67.14, or any mean above 69.86, that's going to be considered unusual. Okay, so when you see on the quiz or the test, anything about sample mean, you're going to use standard error, right? You're going to plus or minus the standard error times 2. But if you see something about a individual score, you're going to use standard deviation plus or minus 2 times. Okay? Does that make sense? Anybody? Questions? Okay, so you need to go in and do this for yourself. Okay, you need to go in to the practice homework. You need to run the descriptive statistics. You need to draw out those normal curves, put the data on it, look at the standard deviations or the standard errors, you know, do that plus or minus yourself, you know, just really get that into your head, okay? You also need to figure out, I will send you, in an announcement, I'll send you a document that just has a simple array of data that you can figure out standard deviation by hand and means and medians, the mode, the range, because you'll have to do that all on the quiz by hand. Okay? Any questions? Okay, so please, please, please watch the videos, go back through the lecture, do the practice homework before you attempt the actual homework and the actual quizzes, okay? Please prepare and study, okay? Because I don't want you to just jump on there and be like, oh, I got it. And then all of a sudden you're like, oh crap, I don't got it, okay? Make sure you prepare ahead of time, okay? I'm not making this quiz and homework is not due until end of the day on Friday. Okay? End of the day on Friday for this. Unless you're ready, you know, unless you get prepared and you feel good about it and you're ready. Okay? Questions, comments before we go? Okay, I'm going to stay on. So if there's anybody that needs to talk to me or if you just want a little bit more explanation, then you can do that. Otherwise, I'll see you tomorrow at 10:30 a.m. Thanks for hanging with me.